Hello everybody, welcome to our next to last section here. Here's graphing with polar coordinates. There's a lot of practice problems at the end of it. I know it says that they're homework, but basically they're just for practice and you can give them a try. I won't be collecting it like it says. So anyway, first thing we're going to want to do when we do these kind of things is we're going to want to look for symmetries. Now, we used to have symmetries that we really looked for, which were odd and even symmetries back in Cartesian coordinates. And it would be odd if f of negative x equaled negative f of x, and then it would be symmetric about the origin. And if it was even, then f of negative x would equal just f of x, and it would be symmetric about the y-axis. Okay, so we had these two main symmetries, but now we're going to look at the three types of symmetries here we're going to get in polar coordinates, or polar graphs. And so first is symmetry about the x-axis. This is going to be true if the point r theta lies on the graph, then the point r negative theta, or negative r pi minus theta lies, notice it's an or, not and, lies on the graph. So here, if you look at the figure, you can see that right here, where we have r theta right here, and then if we do negative theta, right, negative theta instead of theta, we end up getting the same point but symmetric over, and that would work over here if we had some angle over here, right, where this was theta, and we could come around to negative theta and do the same radius, and then we'd have that mirror image across there as well. So that's our, still can't get it to erase. That's our symmetry across the x-axis. Next is symmetry across the y-axis. A lot of times you might see people refer to this as symmetry around theta equals pi over 2, because the line theta equals pi over 2 is the y-axis. And so if you ever see that, that's what they're talking about, the y-axis. You just go to the angle pi over 2, which is pointed straight up, and that would be your y-axis graph. So anyway, we'd have symmetry about the y-axis, and here what's going to happen is you're going to either have the r pi minus theta for r theta, or negative r negative theta. And again, notice it's an or, not an and. So, you know, one or the other. And actually sometimes you might want to check, just check both when we get to doing it. But anyway, if you look over here, that's this graph right here. Where is it? It's this graph right here about the y-axis, and you can see here's our theta, and then here is r, and then what we're doing is going to pi over 2 and then back a theta amount. So instead of going theta, we went pi. Did I say pi over 2 a second ago? I might have. We went pi and then back negative theta, and so that gets us that one. That's this right here. Or you can do negative theta, so this would be theta, and you can go to negative theta, and then instead of coming out r this way, you go r in the negative direction, and that takes you there, right to it as well. So either one of those ways is going to get you that one. And then the last symmetry we have is symmetric about the origin. Here, all you're basically doing is negating r, or adding an extra half a rotation to theta. And you can see that here in this picture over here. You just go theta and then go out r, or you go theta and then go negative r. And that'll get us to points right there that are then symmetric about the origin. All right, so let's take a look. I don't need all those circles on there. Let's take a look at this first example. We're going to do this one. So the first thing we want to do if we want to graph this is we want to check out for symmetries. So let's start with the x-axis one. In this one, we're just going to let theta equal negative theta. If you look back up here, back over here, that was what the difference was, theta to negative theta. Okay, and we're going to check and see if that works for us. And so let theta equal negative theta, and we can have r equals 1 minus cosine of negative theta. And if you think about it, if you remember, cosine of negative theta is actually just equal to cosine of theta. Look up here, if you're on your unit circle, any theta you go to, say in the positive direction, say you go over to here, if you just do the negative amount of theta, you're going to end up in the same location on that x-axis, and so therefore, cosine of negative theta is equal to cosine of theta, so this is just 1 minus cosine theta, which means it passes that symmetry. So we are going to have symmetry across the x-axis. The next one we can check is for the y-axis, and what we can do here is, on this one, we had to have both theta equal negative theta and r equal negative r. So that was basically this part right here, so we'll take a look at that, and then let's go ahead and give it a try. We'll get, we're going to let theta equal negative theta and r equal negative r. We're going to swap them over to that. I should maybe not equal, but change to. And so we're going to get negative r equals 1 minus cosine of negative theta. Now here, this cosine of theta, just like as before, becomes just cosine of theta, but negative r stays negative r. And we can't do anything more with that, so this does not work. So that one's out. Maybe I should put a green check mark here. This one did work. Okay, that one worked. This one did not work. And we can even try the other symmetry over here, which was the letting it be r, and then theta becomes pi minus theta. So if you want to try that, we can let theta basically become pi minus theta, and we get r equals 1 minus cosine of pi minus theta. And so if you compare cosine, sketch on your unit circle, so we look at some cosine of some angle, so let's say we have this angle right here, this angle theta, and what happens is we end up with this angle theta here, we get this x coordinate, whatever it happens to be over here, it's going to be some negative x coordinate, and instead what we're doing for our check is we're going pi this way, and then we're going to go back over theta amount, and so that's going to put us over here. That's the pi minus theta, and you know that if we look at the x and y, the x coordinates on here, this one will be positive, this one will be negative, so they are actually just, our cosine will just be negative of what it was. And so r will equal 1 minus negative cosine of theta, like that, which means r is going to equal 1 plus cosine of theta, which means, again, that's not the same as what we started with, so this is a big old failure. And those were just for y-axis symmetries. It didn't work in either case. If we wanted to check the symmetry about the origin, might come up here. The origin, all right, for this one, so x-axis, origin, y-axis. For the origin, remember we're only gonna negate negative r. We don't have to do both of them, but let's take a look here. We're gonna make this negative r equals 1 minus cosine theta, because we're let r become negative r. And here you can see that's not gonna work. That's not gonna be the same. Even if we divide both sides by -1, we'll have -1 plus cosine equals theta, or equals r. So this one, failure. We do not have symmetry about the origin. So we only have symmetry about the x-axis. So what we can do is just actually go through and plot out a few points to see what this is going to look like. So let's start with theta. All right, and we can do a few of these. Let's do 0, pi over 3, pi over 2. Remember, we have symmetry across the x-axis. So once we get, we really don't need to do anything past pi, because once we get this top half, we can just mirror image it into the bottom half and we'll be good. Oops, sorry. So we can just go ahead and just stop once we get to there. So let's do 2 pi over 3, and we can stop at pi, see where pi goes to, okay? And so we're just staying on that upper half because we have that symmetry, which means we don't need to start checking like negative 2 pi over 3 or 5 pi over 3 or stuff like that, okay? We can stop there. So we can figure out what the cosine of theta is. So the cosine of 0 is 1, the cosine of pi over 3 is 1/2, the cosine of pi over 2 is 0, the cosine of 2 pi over 3 is negative 1/2, and the cosine of pi is negative 1. And then we can do 1 minus the cosine there, and so we'll get 0, we'll get 1/2, we'll get 1, we'll get 1.5 or 3/2, and then we'll get 1 minus negative 1 is 2. And so then we get our coordinates are theta, and so what we get here is this is r, right? This is r right here. So we'll get 0, 0 as a point. We'll get 1/2 pi over 3 as a point, right? I'm picking this column is r, and just to be clear, this column I'm getting from right here, these thetas, okay? And so then we've got 1 pi over 2, we've got 3/2, 2 pi over 3, and then we have 2 and pi right there. And so we can just go back up and start plotting some of these points. So 0, 0, that one's going to be right there. We're going to have 1/2 for the radius, and then an angle of pi over 3. So that's going to be, we've got pi over 3 right here, and this is 2, so this is 1, so this is 1/2 on this little circle. So we go around there till we get to pi over 3, and we put a point right there. And then we've got 1 and pi over 2. So pi over 2 is up here. This is the one circle we go around. We get to it right there. Maybe we should do those in a different color here. We're going around that much and around that much. And now the next one, what did I just do? 1 and pi over 2. So then we need to do 3/2. So that'll be out at 1.5, which is on this line right here. Well, I thought I said I'd do that different. So that's on this line right here, and we're going to go around until we get to 2 pi over 3, which is right there, which means that's where that point goes. And then our last one is 2 and then pi. So we go out to the radius 2, and we go around till we hit pi, and our last point goes right there. And so if we connect these points, we get a shape like this. That wasn't very good. It's going to be like that. And then all we have to do is mirror image this around down on the bottom, and you get something like that. Okay? And so there we go. We've graphed it. I could have gone through and actually maybe should have picked out like these points and mirror imaged them and said, oh, like this point is where, right? How many out of my 1, 2, 3? 1, 2, 3. It's like right here, and that point stays there, and there's some other point here. This point is there. I mean, like I could have gone through and maybe done it a little bit nicer, but anyway, you get that shape right there. Okay? So let's go ahead and go on, do another example here. So this is r squared equals 4 cosine theta. So let's check for symmetry. Okay, I think there's 2 m's in that. So let's go ahead. Let's start with x-axis again. And so for x-axis, we let theta equal negative theta, because that gets us to flip across the x-axis. And so we get r squared equals 4 cosine of negative theta. And again, just because of before, cosine function is even, so r squared equals 4 cosine theta, which means good. We got that one. Check mark. Okay, we have that symmetry. Next, let's do y-axis. And here we're going to go should have made this a go to. We got to let r go to negative r, and theta become negative theta. And so this becomes negative r squared equals 4 cosine negative theta. Now here, this is negative r times negative r. That's just r squared. This is 4 cosine negative theta. Again, it's even, comes cosine theta. So that's a big check mark again. We got this one. This one worked, and we're set. Okay? And so next, let's try about the origin. Come up here. And origin. And here, what we want to do is do the only other option, right? We can let r go to negative r. And again, we get negative r squared equals 4 cosine theta. And again, that negative r times negative r is r squared, which is 4 cosine theta. And so this one passes as well. So we have all three types of symmetries. And so the question is that I want you to ask yourselves is, if it passes the first two symmetries, will it always pass the origin symmetry? So think about that one. Okay? So let's go through here. We have all these kinds of symmetries, the y-axis, the x-axis, so we really only have to do one quadrant and then just start doing our symmetries, our x symmetry and our y symmetry. So all we have to do here, let's do the same thing. Let's go theta first. And let's not even leave the first quadrant. Let's start 0, pi over 6, pi over 4, pi over 3, and pi over 2. Let's do these real easy ones right here. And so cosine of theta is going to equal cosine of 0, 1. Square root of 3 over 2 is for that one. Square root of 2 over 2 for pi over 4. 1/2 for pi over 3, and 0. And then we need our r, which is equal to r is equal to the 4 cosine theta, or sorry, r squared is equal to 4 cosine theta. So we need plus or minus 2 square root of cosine theta. Okay? And so what we're going to get here is plus or minus 2. We're going to get plus or minus, what did this one turn out to be? It was plus or minus 1.9 and plus or minus 1.7. Yes, calculator on this, plus or minus 1.4, and then 0 again. And then what we can do is take a look at our r theta, and again, r's are coming from there, so we'll have a plus or minus 2. We aren't going to really need it because of the symmetry. The symmetry is showing up. We're going to have a plus or minus 1.9 and then pi over 6, and then we'll have a plus or minus, really any of these we could have done for cosine, because cosine's even, we could have put plus or minuses on these as well if we'd wanted, and then we would have just ended up with the same cosine value. So we could be putting plus or minuses on these angles, but again, it's all just the symmetry showing up. So I really don't need to be putting these plus or minuses. So 1.7, so I'm going to stop. Otherwise, what's the point of having found the symmetries, right? So pi over 4, 1.4, pi over 3, and then 0 and pi over 2. Okay, so we can come back up here. We can plot these points, and we can go to 2, 0. So that's just right there. We can go to 1.9 and then pi over 6. So 1.9 is going to be just inside 2 at pi over 6, so right there. And then we can go to 1.7 pi over 4. So this is the pi over 4 line right there, right? This one here is the pi over 4 line. That's our angle there. And so we need to go out to 1.7. There's 1.5. There's 2. So we're a little under halfway between them. So maybe right there. And then we need, what was that one? 1.4 and pi over 3. I'm gonna make my dots a little bigger just so when I actually draw this in, it works a little better. And so anyway, 1.4 and then pi over 3. So here's the pi over 3 line, and then we go to 1.4. So a little under 1.5. So we're talking like right maybe there. Again, bigger points to help myself. And then the last one is 0 pi over 2. Well, we have a 0 radius, so we're going to end up right there, no matter what the angle is. And if you trace and draw this one in, what will happen is you'll get a shape like that. And then you could go through and just mirror image these points over to all the other places, which you probably should do, but basically you're just going to get this and then mirror image it over across the other axis. Maybe a little better than I did, and then down like that. And so you'll get some graph kind of like that. And maybe I should do, this is 2, 0, that's 2, 0, this is that one, this is that one, this is that one, and then the last one, I'll just color coordinate these for you, that one is that one. Okay, and so that's basically how we went through and did that. All right, so that's basically what I really want you to know how to do for this, is just kind of going through and being able to graph these just like that. Okay, so don't worry about the don't really worry about converting from one plane to the other. We're not going to mess with that. So we'll take a little break from that with everything that's going on, and we'll stop right there. So you can basically, pretty sure you can just basically ignore that page, ignore this page, but try some of these. Here's some practice ones. I gave you some practice homeworks, but go ahead and try some of these. There's quite a few of these practice problems here. I'm not going to go through and put them all in, because you can just hop on, any graphing tool you want, Wolfram Alpha or something, and graph them. If you have a graphing calculator, put it in polar coordinates, type them in, and see if you're correct after you try them. But just some practice for you, something that's not too crazy difficult. All right, that's all.